Have you ever looked up at the sky and wondered, why is it blue? It's a question that has crossed the minds of many, from curious children to seasoned scientists. This question has puzzled humans for centuries. Ancient civilizations, philosophers, and scholars have all tried to understand the mystery behind the sky's color. We gaze at its vastness every day, marveling at its beauty, but the reason behind its beautiful blue hue isn't always obvious. It's a daily wonder that often goes unexplained. Well, get ready for some cool science. The answer lies in the realm of physics, where light and particles dance in a fascinating interplay. It's all thanks to a fascinating phenomenon called Rayleigh scattering, named after a pretty smart guy, Lord Rayleigh. His work in the 19th century helped us understand how light behaves in our atmosphere. The sky's blue color is like a magic trick, a beautiful illusion created by the way sunlight interacts with our atmosphere. When sunlight enters our atmosphere, it collides with molecules and small particles, scattering in all directions. The science behind it is really neat, and we're about to break it down in a way that's easy to understand. Imagine sunlight as a beam of white light, composed of all the colors of the rainbow. So, buckle up, science fans. As this white light passes through the atmosphere, the shorter blue wavelengths scatter more than the other colors, spreading across the sky and giving it that iconic blue shade. Let's explore the amazing world of light, color, and the mysteries of our blue sky. By understanding Rayleigh scattering, we not only appreciate the beauty of our sky, but also gain insight into the fundamental principles of light and color. Next time you look up and see that endless blue expanse, remember the incredible science at work. It's a reminder of the wonders of our natural world and the joy of discovery. And as the day turns to night, the sky continues to captivate us, shifting from blue to a canvas of stars. The journey of light doesn't end with the day. It transforms, offering new mysteries and beauty to explore. So keep wondering, keep exploring, and never stop being curious about the world around you. The sky is just the beginning of the many wonders waiting to be discovered. Stay curious and let your imagination soar as high as the sky above. To understand why the sky is blue, we need to first picture sunlight's journey to our eyes. Light from the sun looks white, but it's actually a mixture of all the colors of the rainbow. Think ROYGBIV, red, orange, yellow, green, blue, indigo, and violet. Now imagine sunlight as a bunch of tiny waves traveling through space. When these waves enter the Earth's atmosphere, they bump into all sorts of stuff like gas molecules, water droplets, and even dust particles. It's like a wild obstacle course for light. These collisions scatter the sunlight in different directions. But here's the catch. Not all colors are scattered equally. This is where Rayleigh scattering comes into play. Rayleigh scattering is like a tiny dancer that prefers shorter wavelengths of light. This phenomenon is named after the British scientist Lord Rayleigh, who first described it in the 19th century. It's a fascinating process that plays a crucial role in the colors we see in the sky. You see, blue and violet light have the shortest wavelengths, which means they are more easily scattered by the small particles and gases in the Earth's atmosphere. On the other hand, colors like red and orange have longer wavelengths, which makes them less susceptible to scattering. This is why, during the day, the sky appears predominantly blue. When sunlight hits those air molecules, the blue and violet light gets scattered much more than the other colors. This scattering causes the light to spread out in different directions, filling the sky with these shorter wavelengths. It's like trying to dance a waltz with a bunch of ping pong balls. They're going to bounce around like crazy. Imagine each ping pong ball as a particle in the atmosphere, and the blue and violet light waves as the dancers trying to move gracefully among them. This scattered blue and violet light fills the sky, making it appear blue to our eyes. However, our eyes are more sensitive to blue light than violet, which is why we see the sky as blue rather than violet. It's like a giant blue canvas painted across the atmosphere. This beautiful blue sky is a result of the intricate dance of light and particles, a natural masterpiece that we often take for granted. So, the next time you look up at that clear blue sky, remember those tiny dancers, the blue and violet light waves, putting on a show just for you. It's a reminder of the wonders of nature and the science that explains it. Every glance at the sky is a glimpse into the complex interactions that create the world we see. Sunsets are not just a simple end to the day. They are a spectacular display of nature's beauty and science combined. Every evening as the sun begins its descent, we are treated to a mesmerizing show of colors that can leave us in awe. These stunning sunsets with their fiery oranges and reds are a result of the scattering of light by the atmosphere, a process that becomes even more pronounced as the sun sets. When the sun is low on the horizon, its light travels through more of the Earth's atmosphere, causing more scattering of the shorter blue and violet wavelengths. This means the shorter blue and violet wavelengths get scattered away, so we mostly see the longer wavelengths of light, the oranges and reds, reaching our eyes. Each sunset is unique, influenced by factors such as particles in the air, humidity, and even pollution, which can enhance the scattering effect, creating more vivid and dramatic sunsets. So next time you witness a sunset, take a moment to appreciate the science behind the beauty. It's a daily reminder of the wonders of our natural world. Whether you're on a beach, in the mountains, or simply in your backyard, sunsets offer a moment of reflection and awe, reminding us of the day's end and the promise of a new beginning with the dawn. Here's a fun fact. Did you know that on Mars the sky appears reddish during the day? That's because the Martian atmosphere is much thinner than Earth's, and it's filled with dust particles that scatter red light more effectively. So, instead of a blue sky, you'd see a reddish one on Mars. Our blue sky is a reminder that we live on a planet with a unique atmosphere that makes life possible. It's a beautiful example of how science and nature work together to create the world around us. So there you have it. The next time someone asks you why the sky is blue, you can impress them with your scientific knowledge. You can tell them it's all thanks to Rayleigh scattering, those tiny dancers of light that prefer blue and violet wavelengths. Remember, science is all around us, even in something as simple as the color of the sky. Keep asking questions, keep exploring, and never stop being curious about the world around you. And hey, if you ever find yourself on Mars, don't forget to take a look at that reddish sky.